We are going to use a pulley and drop a golf ball into a cup, and while the cup with the ball will drop down, the other side will shoot up and it will be tied to a piece of paper that holds the car. This shows Newton's third law because the weighted cup on the ground had an opposite and equal reaction to the cup with the ball in it going down.
After the paper is pulled from underneath the car falls 12 inches down an inclined plane in 1 second. Therefore, the car's velocity is 12 inches per second downward before it crashes into the dominoes.
The car is going to hit the first domino, and its resting force will now be thrown into action as it hits the next one and creates a domino effect which will finally hit a golf ball into the tube. This is an example of Newton's first law because the first domino was at rest until hit by the car, and then it hit the second domino, which created the effect.
The ball then enters the black tube and falls before hitting the car. By multiplying the ball's mass of 0.0459 kilograms by its velocity squared of 12.11 feet per second and then dividing that by 2, we can calculate the kinetic energy to be 0.278 of a joule.
The car will then shoot out of rest and roll down the ramp to eventually hit the golf ball. This action by the car is an example of rolling friction because the friction is acting on the rolling car. The mousetrap, which is tied to a piece of paper holding the marbles, will then spring into action because of the weight pressed onto the pressure plate by the golf ball. The jolt of the mousetrap will pull the string from in front of the marbles. This is an example of Newton's first law because the mousetrap is at rest until the force of the golf ball acted upon it.
After the paper holding the marbles is pulled, the balls travel down the ramp before hitting the first domino. Using Newton's second law, we can calculate the force by multiplying the marble's mass of 0.015 kilograms by its acceleration of 8.42 centimeters per second squared, which ends up being 0.126 of a Newton.
The marbles will then hit the first domino at rest and create another domino effect that will end with it hitting a string. This domino effect is an example of Newton's first law because the dominoes were at rest until hit by the marble's force, which ultimately led to the effect. The paper holding the car is pulled when the string is pulled by the book falling. We can calculate the book's kinetic energy while it is falling by multiplying the mass of 0.2 kilograms by the velocity squared, which is 73.469, and then dividing it by 2, which tells us the book's kinetic energy of 7.347 joules. The car will then shoot out of rest and roll down the ramp to eventually hit the golf ball. This action by the car is an example of rolling friction because the friction is acting on the rolling car. After the car taps the golf ball into the tube, it experiences sliding friction as the tube's tightness slows the ball down before it pops out and flips the switch to turn the lamp on.